Hey guys, so this is my Ender 3 Pro from Creality, my 3D printer here. And I just want to show you the main thing I found gives success when printing with ABS. As you can see here, I have the Batters Hackers regular ABS black. And the only thing I changed on the printer since I bought it, so I bought their glass bed that has this, like, I don't know how it's advertised, but it's on their website, like a carbon silica texture to it, so that it helps adhesion when the print goes down. I don't use any of those like adhesive hairsprays or whatever to help the part stick. And I'm heating up the part right now. So as you can see, the bed is heating up to 110 degrees Celsius. That's what this thing is maxed out at. And just the bed mod will not give you any success with ABS. So after some trial and error with what I was trying to find as the main source of the problem with ABS was you can't have any air, breeze at all touch the part, or it will instantly lose adhesion to the bed plate and warp and just completely screw the print up right from the start. And once I made this mod, which I'm going to show you here in a second. Now I know there's a lot better materials out there such as PETG to use with this printer, which is probably what I'll switch to next, but the main source that I wanted to use the printer for was to print automotive parts, and PLA will definitely not handle the heat. I've had PLA parts just warp in the sunlight, so I'm going to be using this to make various automotive parts. I've made some center caps for my racing wheels for the S2000. I'm going to make some more of that so I have some spares. But they will see rather high temperatures, so the highest temperature rated material I can get is my goal. So here's just a quick look at the one thing I found is the biggest key thing you need to do to this printer to allow it to print ABS successfully, even on an open frame. And that is to tape off the entire underneath. Now this is like HVAC duct taping. It's not foil, so it's a little flexible, but I kind of built an air scoop so that the intake air comes in through here, and right now the part fan is off, but from what I found, the part fan and the hot end fan are both like the same thing. They both blow air like straight down at the part. Just because of the sheet metal construction, there's really gaps everywhere. If you turn the part fan off, there's no way to turn the hot end fan off. Obviously you don't want to turn that off, but it just continuously blows air down at the ABS print. Whether you have the part fan on or off, this hot end fan will always cool the part. Which you don't want with ABS. You want to keep it as hot as possible on the 110 degrees Celsius bed. So I kind of just built an air scoop with some HVAC tape. It kind of looks pretty ghetto, but I sealed off the nozzle and no air can touch the part now. And on the back side, I built a little scoop that directs the air upward. So it kind of shoots in at the hot end, exits the backside, and flies upward away from the print. And if that's the case, you'll never have a problem with any cool air hitting your print and causing it to warp. Now, for bigger parts, I'm sure the edges may have some negative effects. So this is like the one thing I think you need to do to even be remotely successful with printing ABS. If you don't have the air completely blocked off to the part, you will never have a chance on an open frame printer with ABS. Now, the only negative setup about my duct there is it kind of does get temporarily crushed when it zeroes out, moving to the left. And it's still a little bit crushed when it lays its test strip down. As you can see, it kind of had a little glitch there, but now it's purging itself out, it's doing its test strip. And now it's doing the first layer of the print. You can see the ABS would generally pull up at this point already. It would already kind of just peel off, and this would be kind of zigzagging everywhere and not doing anything effective. But when I do print with ABS, I always print with a brim, so it does maybe 10, 11, 12 layers of a brim around the part that you just snap off when you're done with the print. And that helps the adhesion to the bed as well. Alright, we'll check back here in a minute once it gets a little further along. You can see we're about half hour into the print here. Still perfectly no problems. No warping, no separation from the plate. Temps are maintained at 235 nozzle and 110 degrees Celsius bed temperature. It's probably the 6th or 7th part I've done in ABS with zero problems. I can just walk away from this thing starting to get pretty confident there will be no issues. Alright, so the part just finished. I'm going to let the bed cool down to below like 60 degrees Celsius, and then you should be able to just touch this part and it'll pop off the tray. But right now it's still really hot, so it's going to be adhered to the tray. Don't try to rip it up yet, just let it cool off, be patient. And this is printed in 0.28 millimeter layer height, which is like considered a low quality. I don't really care about the finish on this part. This part's actually a Nest doorbell adapter to offset the angle of a doorbell mounted on siding that I designed, so I don't really care how it looks as long as it's just functional. Alright, so the nozzle is completely cooled down to room temperature and the bed's around 44, so that should be plenty cool enough to grab the part. Just know how to grab it, and it didn't even stick to the bed because once the bed cools off, this thing separates itself from the bed. So as you can see, I have my brim printed around the edge of the part, which helps adhesion. And then there's the part in the middle. And all you do is just break off the brim, and there's your part. So thanks guys for watching. Give this video a thumbs up if you found it helpful. Let me know if you've had success printing with this printer or any other open frame printer with ABS.